so adding a new question on here. Yeah, so I thought I'd do just kind of one more. I like doing this, and hopefully it's maybe helpful to you. So I add another question on here from May 2017. I actually think that one of these problems, well, you know, if you're doing this, maybe you're looking at this in the future, and we haven't done this, but I think we've done one of these questions. I think we did this question as part of a formative assessment, so we should see some of this a little bit, but I thought it's just a good question to kind of look through. I think we did maybe part A, but we'll do parts B, C, and D. So let's take a look here. Let me just pause it and I'll kind of read through it and come back. Okay, so not too bad. It's kind of interesting trace table because we are adding stuff into two different arrays, B and C, and I guess we're supposed to update the contents as we go. So that's kind of interesting stuff there. And I think we'll just, overall, I'm just going to work my way through this data and we'll see what we got. I think there's some interesting things in here, certainly using like has next and get next. I think that's super. We've seen using those loops before, so I think that's a kind of like, I think we've tried to use those loops, and sometimes I like them, sometimes I don't. But kind of interesting to see this in a problem, and we can try and work our way through it. And just being kind of aware that it's out there. Okay, so we'll take a look through this one. All right, so yeah, data has next, true. We're just going to start with we had these 4 sets of data in here, so it looks like we'll probably have to run the loop through 4 times, as long as it has next. So true, A is going to be data get next. Okay, so that's going to be value of 2 right now. We're going to say if A is greater than or equal to 0, that's true. Since that's true, we're going to go into here and say A mod 2. So 2 mod 2 is going to, so 2 divided by 2 is a remainder of 0, so that's true. And so then we need to add to B, we need to add item A to that. So if we go to item A, or by kind of B, we need to add the item 2 to that. We might have to keep kind of adding stuff to it. But C, nothing. Okay, so let's go on to that's it for this, right? We finished the if. We're going to go back to the top. We're going to say has next, true. It's kind of interesting there's not a fifth spot down here. We might want to do, anyways, we'll get to that. Next item in there is 4. So is 4 greater than or equal to 0? Yes, that's true. So we go into here. If A mod 2 is equal to, okay, 4 divided by 2 is going to be 2 with leftover 0. So that's true still again. And so we're going to add this to B. So again, it's an array. So we're going to say 2, comma 4. Still nothing in C. Skip the L, skip the end. We'll go back to the top of the loop. Has next? Yes, there's still something in there. A is going to be equal to the data from get next, so that's minus 1. And now, so A is greater than or equal to 0. No, that's not true, so we're just going to skip all of this. So false. And we don't need to do this. We do need to update these values, because I think I saw in another mark scheme where they said, like, if you don't include something there, that means it's empty, which it's not empty. There's still something left in there, so that's fine. Just be safe. I'll go back to the top. There is still something left in the data. And now we're going to say, okay, that value is going to be 3. 3 greater than 0, that's true. And then 3 mod 2 is equal to 0. No, 3 divided by 2 is going to be 1 with a remainder of 1. So that's false. So therefore, we're going to add this item to C, and that's going to be 3. And this is still 2, 4. Let's make sure we continue that down there. Yeah, so that should be good right there. That's A. Alright, it's kind of cool because interesting that they don't do, a lot of times they do a really quick 1-point problem on here, but not in this one. Interesting. Again, it's a very interesting format compared to some of the other problems, because right away here, normally this happens more in part D, but in part B they're asking us to outline the steps, so they're asking us to use like a binary search on this one. Okay. Okay, so how do we use a binary search? This is much more direct sometimes than, this is like asking us to break down a binary search. So let's see, what do we need to do? We know the search value is present in the array, and that initially low is the index of the first value and high is the index of the last value. So basically what we want to do is, so we have an array in here. I'll kind of explain it first, and then I'll so what we need to do is, and I think I've explained this in a bunch of different videos, but what we need to do is to split this data. What we want to do is split this data in half. And we want to, like, we have our search term, and we want to look first right here. And this here, this is going to be like the middle. All right, that's why there's a low and there's a high. We want to search for the value that's in the middle between that. And then we want to see, is middle greater than our search value. And really, maybe to be clear, this middle, these are all indexes. Like it says low is the index of the lowest, of the smallest value, and high is the index of the highest one. So middle is the index of the value in between. So what we want to do is maybe better to say, whatever the array is, array with the index middle, if the value located in the middle of this array is greater than our search value. So if it's greater than, then what that means is that our value must be somewhere in here, because the value right in the middle was larger than our search value, so it must be somewhere over here. So what that means is, if that's true, and maybe I should say like if here, then what we're going to do is say that high is now equal to the middle, and then it's a little bit late, so I kind of like doing these, so I'm going to do an extra one, but that means high is now equal to the middle, because we don't really care about any of this data. We know it's not out there, so high should now be set here, and we need to set middle. Well, actually, probably we need to set a new middle first, because we want to set the middle to be like, say, here. So what we might want to do is, even before this, well, I guess we need to have like a temp value. So let's store the value of middle and temp, and then we want to the high value should be equal to the middle. No, yeah, okay, middle. Yeah, store that value. So now high is there, and now we want to set middle. There you go. Is equal to high minus low divided by 2, which should put it like right here. And then we're going to continue that search until we find the value. On the other hand, and I think as I explain it, I feel like I'm getting a better idea of just how the algorithm works in general. I mean, I kind of know, but like, just as a reminder to myself, I guess. On the other hand, if high is, and there's one thing we probably should have done, because what I'm thinking about is there is actually a better way that we could have done this. So on the other hand, if it looks like this, if this is low, this is high, this is middle. If on the other hand our value is bigger than the middle, that's somewhere over here, then we need to cross out middle, move lower here, and then put middle somewhere in the center here. Which you can see is going to be very similar to this, but just a little bit different. Yeah, now one thing we should probably do right at the very beginning is check to see if the middle value is, like, first thing we should do, 1, calculate, I don't know if I spelled that, calculate the middle index. High minus low divided by 2. We need to, first we should really see if middle index, if maybe value at middle index is equal to search value. Because if it's equal to the search value, then like game over. We don't need to search anymore. If it's not, then we need to do these 2 other options. And this should all really be in a loop, because we're just going to be kind of constantly doing this. If the value is equal to the search value, then break. And do we need to return? Because it doesn't ask us to print or return, so maybe break loop. I don't think we need to identify what we're going to do with that. So basically, if our value that we're searching for is in the middle, then great, we're done. We can just report where the location is. Otherwise, we need to check to see if it's higher or lower. If the value is lower than that middle number, then we're going to use this. If it's higher, we're going to use this. And let's just kind of see. I feel like I've gone through how the code would look. I don't want to just repeat and write what I have here, like rewrite this. But I think we start a loop, calculate the middle index, check to see if our value is located at the middle index. If it is, end the loop. Otherwise, we need to set the figure out if the search value is greater than the value at the middle index. If so, then we're going to do all this stuff kind of in here. Otherwise, and actually I guess probably, yeah, I guess we could just do else here, right? Because this is the only other option. And otherwise, we would do something, and this would just look like we would say temp is equal to the middle. It'd be really similar, but temp is equal to middle, and then we'd say low is equal to middle. And then, actually, we don't need to do this part. We don't actually need this part because, let's see. Yeah, because we're going to calculate a new middle here no matter what. So we might not even really need, I wonder, we probably don't even really need this. I don't think, no. Because we're going to, yeah, I don't think we need this at all. We'll just move high to be where the middle spot is, and then we'll calculate a new middle no matter what using our loop. Or if we'll move the lower up to the middle, and no matter what, we're going to calculate a new middle using a. We could include that in here in both places, but it's just, why bother? It doesn't really seem like it's necessary. Whew, that's a lot of talking. Maybe I'm tired and talking more than I should. Give me a second. Okay, so we're looking back at it. This is interesting. They're saying that these cells could be left empty, but I know we looked at another mark scheme where it said if these cells are left empty, then it assumes that there's not anything in there. Like, sometimes IB is not so consistent. But okay. Let's see. Search value can be calculated from high and low. Good. Yeah, so we have that. Yeah, there we go. So this is basically what I did. Yeah, I think that pretty much covers it. I was making it a little bit too hard, I think, in here. I'm just trying to do like the middle and all that. I don't think I needed to do all that. Easy to just calculate it at the beginning. Okay. Yeah, that should be good. All right, let's move on to C. Okay, so moving on to part C here. Yeah, I took a look through it. There was some parts that I had to kind of reread and maybe a little bit tired, but that's okay. Because it took me maybe a second to kind of think about what they were trying to say here. But basically, we have a collection of numbers, or a collection called numbers, I guess. And basically, we want to save this. First, take this numbers and then save it into an array. And then we're going to search through that array to try and find number S. So one thing that I looked at that was kind of like, what are they talking about here? You said you can assume that the array is large enough and that the collection is not empty. So I was like, okay, is the array not empty? Because sometimes they seem to kind of conflate using a collection and an array at times. But the collection, I think in this case, is talking about numbers, and then the array is talking about D. So basically, you don't have to deal with an empty collection of numbers, and the array is large enough to put everything in. Okay, so that's good. So kind of, and then we're going to perform a linear search. That just means we're going to search through every value in D, and then we're going to output whether it's found or not found. Okay, that's not too bad. Let's check out C. Okay, so the first thing we need to do is take input from the user, and that's going to be saved as S, as they told us. The other thing that we need to do is to read in the values. So basically, read in the values means we're going to take the values from numbers and then put them into the array D. So let's do this. I'm going to do this with an index. I just feel a little bit more comfortable using this. I'm going to use K as my index value, or as my index tracker. And then I'm going to say loop while. And so what I want to do, I need to loop through the numbers collection. So I'm going to loop through numbers as long as it has next. And there's probably different ways we do this, like we talked about using a, we could use another different value for the index here, like M or I or whatever, and then use that, apply that to numbers. I think this is going to be a little bit easier because we don't know the size of numbers. There's other ways we can get around it. We've talked about like 3 different styles of loops for this. But, okay, so loop while numbers has next, and then we basically want to put the values from there into our array D. And yeah, I don't think we really need to declare D, so I'm just going to say dk is equal to numbers dot get next. And then k is equal to k plus 1, so we're going to increase the value of k as we go through, and that should take care of, man, I don't know why I get tired sometimes. My spelling is just like gone. I can't actually spell. But okay, so I think this is going to do this part. We're going to read in the values. We take them all, save them in our array D, and now we just need to perform a linear search on the array D. So that just means going through the entire array and just basically seeing if we can find the value or not. Let's see. I think all we do is just need to do an output, like run through loop. And I'm going to again use the loop while thing here. And I'm going to use this. I just feel like this. Yeah, I think there's a. What could I do? I mean, I could set k back to be equals 0. Yeah, I think I liked using k here because we need to know the index value for D in order to put all the numbers in the right spaces. So I feel like this is a good use of having an index and an increase in the index. Here, I'm just pulling data out. I'm not putting it anywhere. I mean, yeah, I just think there's a lot of different ways to do this. I'm going to do the way that I think I'm most comfortable with. So I'm going to say loop D, loop while D has next. And then I'm just going to say if d.getNext is equal to s, let's see. I mean, okay, so I know like if, so output, I wonder, how am I going to deal with a not found though? Because I can't do else here, because then it would like every time it runs, if I put like this, and I'm going to do a bad answer here, and I'll explain why it's bad. This is not good. This is never a good idea to write down the wrong answer for students, but this is not good. And the reason it's not good is because then that means like, okay, every time we run through a different index in the array, if it's there, it's going to produce found, great. But if it's not there, it's going to say not found. But that doesn't, just because it says not found there, doesn't mean it's not somewhere else in the array, right? It's just not in that particular spot. So we need to do a better job of this. I'm trying to think of the best way that I could do that. I could set some sort of like Boolean value to be like true or false. It seems like there's an easier way to do this. But I could set some value to be um, like I could make a value up here called like found. And I could do Boolean, or I could say found is equal to 0. And then like just kind of test, okay, if Boolean.next, if at any point in here the value is equal to s, and then we'll say found is equal to 1. And then we can just say at the end, and I'm curious to see the answer on this one, because this is how I'm going to do it. I think it works totally fine. If found is equal to 1, then I can actually spell print or output found. Else print not found. I think that's a pretty elegant way of doing it. I'm wondering if there's probably a better way, but that's what I'm going to do. All right, let's take a look at the answer here. Let's over a little bit. Okay, so we're taking the input. They're doing count in here. Yeah, so this is basically identical to what I've done here. Yeah, identical. Great. Oh, good for me. Oh, and they are going to do what I did. Found is equal to false. Yeah, so they're going to use that value to kind of track, and it's called like kind of like a flag. You keep this flag set to be false because like default is that we don't find it. Because if you search all the way through, if you set the flag to be false and you search all the way through and you don't find anything, then just the flag just says set the false, and you get to the end, and then you can print out, yeah, it doesn't change. So we just print out, if it stays false, then okay, we never found it. If it ever changes to true, then that kind of like flicks the flag and lets us know that we did catch it, and then so that's what we're gonna do here. I thought there might be a better way of doing this, but yeah, that's gonna work. Uh, that's kind of interesting using their looping while found is equal to false. So that way, as soon as you find the value, you'll exit. Um, that's interesting. They're saying like you have to use a flag here. That's interesting. One mark for the loop and one mark for the comparison and use of a flag. So I think I did that just fine. I think I did the loop just fine. This is fine. Yeah, so I think I'm getting full marks on this one. Correct input of search value and output message. Yeah, I think so. I think actually I nailed this one pretty well. Um, well, X is less than count. Oh, that's kind of interesting. So they're keeping track of count here to figure out the size and then using that here. I don't know. I feel like they could just be more consistent about like choosing one way or the other to do it. I feel like they always do like all these different varieties. Oh, here's a different example. So maybe they'll show us a different way of doing this. Okay. Oh, let's see here. Oh, okay. In this example, they raised on the same loop as reading from numbers. Okay, so basically instead of, so they're going to search through there while they're reading into the array D. Okay. Alright, so they're going to loop through the collection, mark for the assignment of the array, mark for the assignment of the array into the collection, okay. Okay, so we'll get next. Oh, but they still use a flag no matter what. Oh, interesting, so I guess that was the one way of doing that. That's interesting. Oh, okay, moving to the last problem here, D. Binary search can be performed on the array D if the values D are in ascending order, as values are being read from numbers in a D. They are checked to see if they're in order. So okay, so we need to check to see if the values are in order as they go in there. So I think we just need to see, it should be in ascending order, so they should be the smallest values to begin with and the largest values as you go. So I think just you need to temporarily store the value in each index and then just compare it against the next value coming. If the next value is smaller than the previous value, then you're going to output false. So this would probably be something like very similar to using a flag here. So let me see how I would write that. So basically you have this array. Zero, 1, 2, 3. Maybe you can hear my child out there crying. Her mom's there, it's okay. She'll be alright. I've just lost some candy. Alright, so we have this array 0 through 7, and we have all these values in here. And let's take a look at maybe that array, and I'll do another shorter one. 0, 1, 2, 3, 4, and here I'm going to do 5, 7, 2, 3, 1. So in this case, this one is sorted, this one's not. So basically what we need to do is, we need to look through the array. Let's see. Search through array. And we need to store array value in temp. I just wonder, I just feel like it's easier to actually write the code. Yeah, so I kind of feel like I could write this code better than I can describe it. But good skill to practice, I guess. So we need to look through the array, and we need to okay, so maybe we should search through array store. Maybe I'm gonna say store first value. In a temporary variable. Move to next array location. IB's got me writing all in caps for some reason. Location. Compare value here. So all in caps is just gonna compare value at new location with temp value. If new value is greater than temp, let's see, because if the new value is less than the temporary value, then break and report. Don't know why I'm writing all in caps. Can't stop now. Alright, so if at any time we find that the new value is smaller than the temporary value, then break and report the value is not sorted. If loop makes it to the end of the, maybe I should identify at the top that I'm going to start a loop. If loop makes it to the end of the file, to the end of the array, maybe not file's not the best choice there. If it makes it to the end of the array, without like it basically makes it to the end of the array without throwing the not sorted error. And then report sorted. That should be right? I mean, they want to just check to see. They haven't identified how they want us to. It says just check to see if they're in order. So it doesn't say whether it needs to like print something out or just return it to the user. So I think as long as we describe it, it's fine. And so if you're not sure what's going on here, basically we're going to look through here. We'll look at the value here. This is going to get stored as our temp value. And then we're going to compare this temp value against the next value that comes in. And if the temp value is ever ends up being greater than the next value, then that means that they're not in order. So if we look here, like, okay, 3 is 3 greater than 6? No. Okay, that's fine. We'll move on to the next one. This will be temp. Is 6 greater than 7? No. Okay, we'll move on to the next one. This is now temp. 7 greater than 8? No. Okay, 8 is now temp. 8 greater than 12? No, and the 12 is now temp. You see, and we're just going to kind of work our way through that. If we look in here and say, okay, to begin with, we'll set 5 equal to temp, and we'll compare 5 is 5 greater than 7? No. Okay, 7 becomes temp. Is 7 greater than 2? Yes. Okay, then we're going to break this, and I'm going to report not sorted. So let's see how this works, and let's see kind of what kind of points I'm going to lose on this one. I think I have the right idea, but whether that's going to be enough for IB, let's see. They're setting up and changing a flag. It's kind of interesting. Do not accept pseudocode. Come on. Like, what if I want to just write the pseudocode? Okay, so I didn't do a flag here, but I feel like I'm breaking. I mean, they didn't tell me to. I wonder if I would get points anyways here, because it doesn't say anything about like reporting a flag or. So basically, I mean, what you'd want to do here is set the flag to be not sorted, and if at any point, or I don't know, you could do it either way. You could set the flag to be sorted and then search through it if at any point you find the values are. That's probably the best way to do it. Say it's if it's set it to be sorted and then if you search through and if at any point you find that the values aren't sorted, then you flip that flag and you break the loop. Basically the same thing. I just didn't use a flag here. I wonder if I would lose points on that one. I do feel like I basically covered it, but okay. Starting from the second entry, I started from the first one. Why would you want to start from the second entry though? I guess what they're saying here is like starting from this, comparing this to 3. Yeah, okay, so that makes sense. For completing the current value. Yeah, so I think I don't know, maybe, I think maybe it depends on the grader. Hopefully I'd get 3 points out of this, maybe 2.